Now we're going to talk about the enhanced input system, and I need to give you a quick overview before we start diving into the different components of it. So the way I want you to think about this is we're going to have a big, I'm going to draw this as a square. This is going to be our map. I'm just going to call this map. It has a longer name, which we'll talk about later. And each of our pawns is going to look for a particular map that it will use to determine what actions it can take inside the game. So then we need to create actions. We'll draw little squares. These are our actions. Action, got multiple of them, but action, 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 and so forth. So for our map, it holds our actions, and over here we have our pawn, right? This is going to be our ball. Inside of our event graph, inside the pawn, this is where we're going to run our code inside of our blueprint. Our pawn is going to listen for an action, and when an action happens, respond and run some code right here, right? So maybe this is move, for example. We're going to define a move action inside of our map, and our pawn is going to start listening to a particular kind of map. And then whenever it hears that an action took place, it's going to respond by running its movement code. So in order to do this, we're going to need to create a map, an input action, call this I action, and then we need to hook it up to respond inside of our pawn. This is the overall structure in order to understand the basics of it. So let's create the assets that we need for our basic movement for our ball pawn. So control space to open up the content browser. I'm going to create a new folder called input underneath our underscore game. This will just separate it out a little bit more. And inside of input, I'm going to right click and go to the input dropdown. You're going to see input action and input mapping context. This is a longer name, but it's essentially our map. So first, let's create our input action. We'll call this IA for input action underscore move. And we're also going to create our map, which if you right click input mapping context, this is our map. And we'll call this IMC for input mapping context underscore ball. Once we have this, we're going to save both. And we're going to take a look at something. If I open up my input action for move, now what we really want is we want to receive input for WASD movement, in my case, and determine what keys are being pressed, get a direction from that, and then I can do things in code. And what I mean is that if we were to just press a button, right, let's like spacebar or something, this would be tap, right? So this is going to be a true false. Was it pressed or was it not? Yes or no. You could also have a left and right. In this one, it's left and right key. Maybe our game is just about moving left and right and we just jump. There's no up or down. We don't really need that in some games. And actually, I'm going to call the top one over here Boolean because this is the actual type. A left and right would be referred to as a 1D axis. So with the 1D axis, typically you're going -1, 0, or 1. -1 meaning you are pressing it to the left. 0 meaning you're not pressing it at all, or 1 being you are pressing it. Now, in our case, we want to move left, right, up, and down, and we want to process that all at the same time. So down, left, right. This is going to be a 2D axis. Because we have our up, down combining with our left, right, it's a little bit more complex. So now we want something like -1, 0, 1, 1, -1, something like this, right? It's a little bit more complicated. And we're going to receive 4 different button inputs and process that into a direction. So if we're pressing, for example, W for WASD, I didn't have the type over here, this would be a float, for a 1D axis. So for WASD, right, we're going to be holding W for up, S for down, A for left, D for right. And we're going to combine all of those and do something we'll call a vector 2, which is going to be an X and a Y. So our X is going to be either -1 or 1, and our Y is going to be either 1 or -1 or 0, right? So if we're going left, it's -1, 0. If we're going diagonal, it's going to be -1, +1, right? And we can represent this direction, whatever it is, as a vector. -1, +1, right? If we're going diagonal down, it would be +X, -1Y. We can consult our little chart over here. This is what we're referring to when we try to determine what value type. Now, most cases, you're just going to need a Boolean, like yes or no. Was it pressed? Every now and then you'll need a 1D axis, but for us, we're going to do the movement on a 2D axis, and that's why it's going to be the most complex, which is the whole reason for me giving you this chart. It's a little bit more complicated than a standard button press. So let's hop back into Unreal. If we open up our input action move, and we look at its settings, one of the things it's going to ask us for is the value type. Now, because our movement is going to use 4 different buttons for WASD, we're going to combine those into a single direction that is pointing on a 2D plane. And we're going to call that a vector 2D or an axis 2D for the type right here. So we need to combine the 4 different button presses into a single direction that is drawing an arrow on an XY plane. So now that we have our axis 2D assigned, let's actually build it inside of our map. So if I come over here and I open up my IMC_ball, open that up, there's no mappings by default. Now, before I start building this, I want to show you where you can find more information about this, because it's going to seem like a lot and it's going to seem like I'm pulling it out of nowhere. Well, it's actually just pulled from the documentation. If you go over to Docs Unreal, this may change. This link may change depending on newer versions of Unreal. But if you scroll down, this is where I got this information. Down at the bottom, you can see a lot of extra information if you want to know. But right here, when you're creating directional input, this is the default setup for creating a WASD style input. And we're going to use something called modifiers to assign different kinds of properties to each of the different buttons. So this would be saying if we press A, we want that to be negative, or D to be positive, W to be up. We will have to swizzle to make it a y-axis instead of a traditional x, or S being bottom. There's a lot of things you can do with modifiers, but I'm going to essentially take their default here and put it into my system so that I can have standard WASD movement. And we'll talk about this as we put it in, but this is where it comes from. I don't know all this stuff off the top of my head. A lot of times we have to use documentation, and that's normal. So if I come back to my IMC, this is our map. First, let's assign a new map. This is a new input action into our map. If you hit the save button too early, it's going to tell you that there's no input action. So we need to actually define that. Let's add our first movement. If you click the drop down, we only have one input action created. So let's click that. This is our movement action. Well, specifically our move action. And if we expand that, we can define all the different buttons that we want to put into our movement action. Potentially, we could make this cross-platform and do joystick or WASD or whatever else you want. And that's the benefit of having all these extra properties, even though it is very complicated. So first, we're going to do our WASD. Let's start with our W, and we added a new button inside of our action. So we'll type in W, and if we scroll down to keyboard, you're going to see W under keyboard. Click that and expand. And actually, before I do this, I'm just going to create all my buttons here real quick. So let's add another control binding, that little plus button, A, scroll down, keyboard, A, just make sure that you get the right one. I'm gonna do another plus button, type S, scroll down to underneath keyboard and look for S. And lastly, another plus button, click D. So type in D and scroll down to keyboard D. Perfect. Okay. So now let's configure these. Now, the reason why this is confusing is typically the forward direction is X inside of Unreal, but we want to get more generic movement input, right? So we would want the Y to be the vertical and the X to be the left and right. And then we would just want to redetermine, like once we get that input direction, we want to reconfigure it to do whatever we want for each particular pawn. We want the movement to be fairly standard, Y being up and down, X being left and right. Then we can change that in our blueprint code in response to receiving that. So anyways, we're going to use the default one. So W and S are going to be our up and down. So the first thing we need to do is swizzle that. And swizzling just means assign this to a Y instead of the default X. So if you click on modifier, hit plus underneath W, we're going to look for the swizzle input axis values. We're making the W and the S to be our up and down, so our Y. So we're going to need to swizzle our W and our S to make them the Y. So if you do swizzle, expand that, and Y, X, Z, so Y is first, that's what we want. And then under S, we're also going to add a swizzle down here. This is our up and down, so we need our swizzle. Make sure that's on Y, X, Z, perfect. Okay, that's the first one. The second thing is we want our S to be negative. So W is going to be positive Y and S is going to be negative Y. So we need to add another modifier on our S to be negative. So click that and look for negative. Okay, perfect. So our S is our Y and it is negative. So we'll minimize our W and our S. So next is our A and D. Our A is going to be negative and our D is going to be positive. By default, we're looking at our X, so we shouldn't need to swizzle anything. But our A, we do need to assign to be negative. So we need to do a modifier, index, go to negative. So our A is going to be negative X. You could expand this and you could see we have more options. We don't need to change that. So I'm going to close that one out. And our D is our positive X. So really on that one, we don't need anything because by default it's positive and by default it's X. So I think this is it. If we save this, this is our mapping. Now the next kind of complicated part that we need to talk about is how to assign a mapping to a pawn, because I don't really want to start listening for the movement actions unless I'm controlling this particular kind of ball. So I'm going to open up my ball, and by default, it's not listening for input. So we need to attach this map, our mapping context, to our ball, right? Our ball, our mapping context. We need to assign this mapping context that we configured over here to our ball whenever our ball is created. So let's go back to our ball. And in order to do this, to start listening for that, we're going to do this in an event begin play. And I'm going to need to use some nodes here early on before learning more about what they do, just to make this work. So we'll talk about casting later and other things that we're going to do here. Assigning the map is a little bit weird and complicated. So on begin play, when we start, I'm going to right click and I'm going to get the controller. So get controller. This just gets the generic controller. We may want different kinds of specific controllers, but we don't really need a specific controller for this. This is in the base, so we can do a generic get controller. And we're going to drag off the return of our controller. So that's going to be our ball player controller. And we're going to type in cast to player controller. So this is a certain kind of player controller. Now, again, I'm doing this based off of the documentation they have. You might be able to get the player controller and do this too. Maybe that's fine. I don't know the pros and cons of it enough to deviate from the recommendation there. So I'm going to drag off of as player controller, and we're going to type something called enhanced input local player system right here. This get enhanced player system right there. So that bottom one is a big node. This essentially accesses a larger subsystem that we don't really care about for now, but we want to tell it to add our mapping context to our ball. So I'm going to drag off of this and type in add mapping context right there. We'll connect our pin, and underneath the mapping context, it's asking what map do you want to assign to this ball being controlled by something. And I'm going to choose the IMC ball right here. Now, one extra step that is in the documentation is if you drag off of enhanced input local player subsystem and you type in is valid, you go to the bottom one with the question mark right here, click that one. This is an extra layer of protection saying that make sure that our mapping context is actually good to use before we assign it. So it's good to have that little defensive layer right there. Okay, so this is weird and confusing. Don't worry too much about it. Just know this is how you assign a map to this pawn that is being controlled by something. Hit compile, hit save. So we need to make sure that we're actually listening to it, and we're going to do a little debug here. So I mentioned that we can respond to an input action inside of Blueprints. I'm going to hit compile save. And if we right click now, because we're listening to the map, and we type in IA underscore, you're going to see IA underscore move. And we have two different options here. We can get the event or we can get the values. We'll get the values later, but for now we want the event. And if we click that, we're going to get a red node. And this is saying when the input action move is triggered by all those buttons that we defined inside the map, if we're listening to it and it's triggered, then we can actually respond. So if we're listening to it here and we receive it, then we'll respond here and we can do things in code. I'm going to say when we're triggered, I'm going to drag off and print string. And then I just want to drag the action value directly into here and convert it. So this is going to convert it into that vector2. Remember, that was our value that we assigned inside of our input action. We're just going to print that off. So it should give us an XY according to the direction. Okay, compile save. I think this will work. And if we hit play and we press WASD, you see it'll tell us the values that we're inputting. So if we hit W, it is Y1. So that means straight up. If we hit S, that's -1, straight down. We hit A, that is -1, x, and d is positive 1x. And you see we can get diagonals and stuff too if we press different combinations, and if we don't press anything, it is 0. Perfect. Okay, so this means that our input is being processed correctly for WASD movement, which is what we want. It's a little bit more complicated, but I think it's a good way to learn about it. So if you want a little additional challenge here, or you just want a chance to practice what we've been learning, which I always recommend, a little optional challenge, which we're not going to really implement, but I think is good practice for you. Make this work with the arrow keys as well, meaning that we can use WASD, but we can add additional inputs for our arrow keys to make it work with either WASD or the arrow keys. So it's going to be just like our WASD, but we're just going to create new ones for our arrow keys. I'm not going to show you how to do that, but I recommend that if you want that feature or you want a little optional challenge, to add the arrow keys right here as well. Now that we are receiving input correctly, I want to show you something before we actually roll this ball. If I add a cube to my scene right here, shapes, cube, I'm going to pull that up. I'm going to hit E to go to the rotation mode. Now you'll notice if I hit W, this is our axes right here. X would be in forward direction this way. If I hit E, it's on the other side. Now the reason this is a little bit weird is if I want to roll this cube forward, like this would be up, right? This would be the forward ball if I were to hit W. Look down at the rotation down here. If I rotate it forward, you see how it's going negative, even though we would think of that being a positive direction. If I roll it backwards, it's actually positive. Okay, so something to keep note of, because we're going to have to invert this later on in code. If I roll left and right though, you see, this would be right is 40, left is negative 40. So this one is correct. So what we're going to have to do whenever we actually put this in code is, in order to get it to move forward, we're going to invert this axis right here in order to roll it this way. So if you're a little confused on why we're doing that, it's just because of the orientation of how rotation works and what side of the object we're rotating it. But we want to move it up, down, left, and right. And in order to align that, we'll just need to flip this in order to move it up. So I'm going to delete this cube. Let's actually put this inside of our game. So I'm going to control space, go up back to the pawn. All right, so I mentioned that we want to invert one of the axes. The problem is right now, when we get our move action, it gives us our action value. So this is processing our input, and it'll give us the -1, 0, 1. Well, I want to do something more with that. And I have a couple different options for ways I could break this down. I'm going to show you the easy one. If I just right click on action value right here, and I say, well, first we're going to break the link. So I can click break link first, right, like that. Or you can, I'll undo this. You can alt click as well. It's usually faster. If I right click now that there's nothing connected to it, I can split struct pin. All this means is that this blue value right here, this is our action value. It's a vector 2. This is using the entire structure, but if I break it down, I can just access the individual components of that structure a bit more easily. So it just kind of breaks it apart so we can view more things. So another weird thing about rotating is when we apply a torque, we have to apply it across the other axes. So like if I were to rotate something, right, in order to move it forward, I'm rotating the Y, but it's moving, like it'll rotate towards the X direction. So if we want to move in X direction, but we rotate X, it's not really going to move that direction. So rotations are just a little bit odd, which means that we're going to have to manipulate these a little bit differently. So if I want to move up, I'm going to take my X, because remember it's reverse, like I just showed you, and we need to invert the positive and negative. Remember earlier when we rotated forward, it was negative. So we're going to pull off of the X, and all we're going to do is multiply by -1. That should invert it. So I'm going to type in multiply. We're actually going to delete this print string. We don't need it. So we're going to multiply our X by -1. I'll pull that out a little bit. And then from that, we are going to reassemble the vector, and I'll tell you why in a second. So we're just going to take it apart, manipulate the X to multiply by -1, and then put it back together. So I'm going to type something called make vector 2D. And my Y is just going to plug directly into there. So I'm splitting it, I'm inverting the X, and then I'm putting it back together. Now, there are other ways you could do this in like the input settings or whatever. I just really want to make this clear to you what and why we're doing it. And to me, it makes sense just to see it here. Okay, now the reason I'm combining this, so this is the other thing that's a little weird to talk about. If we are combining our vectors with 0, 1, and -1, what happens on diagonals is if we imagine a line that is of one length, like from this square right here, imagine we're drawing a line from here to here. This is one length, and then we're drawing it here to here. This is one length. But if we go diagonal, if we combine 1 and 1, this line is actually a little bit longer than this line and that line. So what happens is if you don't normalize your vector, which means just pull it back so it's the same length, then you will move faster at diagonal directions. This can be bad and break your game and create weird speedrunning tactics. So what we want to do is make sure that this line right here is always the same length as we rotate it around. So if you imagine this little blue arrow on my player start, I'm just going to rotate this temporarily. You see how it's the same length all the way around when we rotate it? This is what we want, but we don't get that when we try to combine our 0, 1, and 1, right? This is longer, that would just be weird. So we're going to normalize it so that we get this behavior. So this line is the same length no matter what direction we're moving. And that's why we're going to recombine it so that we can normalize it. So once we recombine the vector 2, we can pull off of that and say normalize 2D. So this will resize the line so that even if it's at a diagonal, it will always be of one length, which is exactly what we want. We'll compile, save. I'm going to move this down a little bit. And now that we have the direction we want to rotate our ball, we need to determine the strength in which we want to rotate our ball. Because in the end, we want a direction and a strength to get our final roll speed or a roll amount or whatever. So let me illustrate real quick what we're trying to do. Right now, we have our direction. This could be forward or it could be whatever direction we want. And we want to apply a particular amount of force in that direction because we might have a different move speed. Maybe we want the ball to move faster in some situations, or we want the designer to control it. So what I want to do is I want to multiply the direction times an amount. So let's say 3. So if we multiply our arrow by 3, then it's going to be 3 times as long, something like that. We're going to imagine 3 different arrows stacked, and whatever direction it is, right? Like if it's this direction and multiply that by 2, then it is twice that length in that direction. And that's just how we can get a stronger force in the direction we want it. We're just going to multiply it by a number, and we'll make this a variable so that we can control it. Okay, so we have our direction here. After we've normalized it, we are going to multiply it by an amount to determine our strength. So let's create our roll torque, we'll call it. So this is going to be the strength in which we want to roll the ball. So I'm going to go over to variables, hit plus, we'll call this roll torque. We're going to change this to float, compile save so that we can set a roll torque default. Now this needs to be a really, really large value. You'd probably want to start close to 1 million. And a value that I've found works pretty well. I'm going to start with 5 million. 1, 2, 3. So 5, 1, 2, 3, 1, 2, 3 for the zeros. We're going to compile save, and we're going to multiply our direction by 5 million, just such a big number. We'll pull off, we'll say multiply, okay, and then we're going to plug in our variable because we may want to change this later and we don't want to just hard code it. So that's why we're putting in a variable, say get roll torque, and we will plug it in just like that. And it was doing a conversion, so it's using a different node to multiply our vector 2 by our float. Should look like that. So we have our direction, we have our strength, to have our final line that we are drawing. And the last thing we need to do is just actually add the torque. So once we have calculated it all out, we're gonna pull off of this and we're going to say add torque. You're gonna see nothing's gonna come up. I mean, I also misspelled it, but if I type that, it's because we need to add the torque to a mesh, and the mesh is going to contain the function that we want to actually add that torque, which means that we need to get access to the mesh to add the torque to. So I'm going to drag the sphere into our scene just like that, pull off of the sphere, and now when we type it in, we will see add torque in degrees or radians. I've been using radians. There's probably some differences there. So we'll use this one, and I'm just going to plug my trigger directly into my add torque like that. And what it is looking for is a vector, or I call it a vector 3, but it's our X, Y, and Z, even though we only have our X and Y for our input. If we plug this in, it's going to convert it for us. It's going to recombine it into a vector 3 and allow us to choose the Z value that we want. Now later on, I'm going to do something with this, but for now, I'm going to leave it at 0 so that we're not applying any Z value either way. It's just going to always be 0. And we're going to hit compile, save, and I think this will work. Let's minimize it and try it out. Hit play. Oh, okay. So if you hit play, you're going to see the camera just going wild. Now the reason is because our spring arm is actually rotating with our sphere, right? Like if you remember that it's attached, rotate our ball, it's just like going all over the place, and we don't want that. So what I'm going to do is I'm going to come to my spring arm. I'm going to tell it to ignore the rotations of its parent, meaning that we want world rotation, not relative. So remember, spring arm, click this little transform next to the rotation and click world. And that should fix it for us. I'll save, come over here, hit play, and we have a ball rolling. Perfect. You see it slides a little bit. It's probably a little too fast. We'll fix that in a little bit. It's working and we can begin to tweak it. Okay, so one thing you're going to notice pretty quickly is that we are not capping our rotation. So we can rotate almost infinitely fast as long as we are holding on the button. So what I want to do is I want to cap that max rotation. We'll call that the angular velocity. And to do that, we're going to open up our ball. Let's go back to our event graph. And I'm going to do this in begin play because I only really need to do it at the very beginning. We're going to set that initial value. So I may want the designer to customize what the max velocity will be. So I want to create a variable. So I hit the plus button. I'm going to call this max angular velocity, hit enter. And I'm assuming this is a float. So what I want to do is I want to get the sphere. So I'm going to drag my sphere component over here. So I'm going to do this in begin play. We only need to do it once. And I'm going to pull off of sphere. I'm going to type set physics max angular velocity in radians right here. And I know that this exists because I just researched it beforehand. You're not gonna be able to memorize everything. Sometimes you just have to look. So let's see, we can connect this up. We're gonna set the physics max angular velocity in radians to this mesh. We give it the target and we need to actually set it to a new value. We don't wanna set it to 0, then it would not move at all. So let's click our max angular velocity. Let's compile, save. And we're gonna set the max to, I think 10 was a good value for me. So let's drag that off. We'll plug that in here. And so that will prevent the sphere from rotating faster than this max angular velocity allows. So once we hit 10, we're just gonna stay at 10, essentially. Now the nice thing about this is because we can give it a very high value to get it rolling quickly, but then prevent it from rolling faster and faster to infinity. It'll just keep rolling at its max speed. So it's pretty nice. If we compile, save, go back and try it out now. All right, so we start rolling really quickly, but we don't actually move infinitely fast. You see, we're kind of capped out. And this feels pretty good to me. Another thing I want to do, which is kind of subtle, is if I go to ball pawn and I go to spring arm, you scroll down a little bit, there's something called camera lag down here under lag. If you click enable camera lag, you can actually mess with some of these settings. I'm gonna put mine at 5. I usually try to keep it between 1 and 10, somewhere around there. But 5 is gonna work pretty well. If I compile save, this is going to make the spring arm kind of lag slightly behind the movement. You'll see it right here, right? When I stop it, it kind of floats a little bit. It's not perfectly in the center. Gives a little bit of cushion in the middle. And that looks pretty nice to me. So I'm going to exit out. So at this point, we have the basics of the movement for our ball pawn. And I think a good challenge at this point might be just to tweak your movement a little bit. So we did max angular velocity. We did roll torque. We did camera lag speed. And we did spring arm offset to place the camera. There are a lot of other ones that we briefly messed with, but I would play around with some of these so that whenever you hit play, the ball moves according to the feel that you want for your game. This will also give you some practice just messing with some of the values that we were toying around with. So once you do that, you should be ready to continue, and we're going to keep adding features to our game. Before we move on, just one little cleanup thing that we want to do. I'm going to make one folder, and we're just going to call this ball game. And I'm going to put all of these major gameplay framework assets inside of our ball game folder. Move here. Okay, we'll make sure that there's no problems. This will just keep our folders more organized when we add things in the future.